Good day, everyone. I am Christian Jericho Kitalig, and today I'll be introducing to you nanobiotechnology, the union of nanotechnology and biology. This presentation will explore how nanotechnology and biology come together to create one of the most transformative fields in modern science. So, before we begin, let's Let's look at our lesson objectives. First, we define nanotechnology. Second, explain the significance of nanobiotechnology. Discuss applications of nanotechnology and nanobiotechnology. Describe the role of nanobiotechnology in diagnostics and medicine, and cite some examples. So, the history of nanotechnology began with physicist Richard Feynman, who in his 1959 lecture, "There's Plenty of Room at the Bottom," introduced the revolutionary idea of building things atom by atom. He said, and I quote, "I want to build a billion tiny factories models of each other which are manufacturing simultaneously." Feynman believed that the laws of physics do not prevent us from manipulating atoms directly, but we're just too big to do it easily. This vision sparked the foundation for all nanotechnology research we know today. Later, in 1974, Professor Norio Taniguchi formally defined nanotechnology as the processing, separation, consolidation, and the formation of materials by one atom or one molecule. This was the first clear scientific definition for nanotechnology. It established nanotechnology as a discipline focused on precision at the atomic scale. In the 1980s, Kim Eric Drexler, often called the father of nanotechnology, expanded on these early ideas. Drexler defined nanotechnology as the engineering of functional systems at the molecular scale. In his 1981 MIT thesis, he introduced the concept of molecular machinery as tiny self-replicating systems capable of assembling materials atom by atom. Later, in his 1986 book, Engines of Creation, he popularized nanotechnology for the public, while his 1992 work, Nanosystems, provided detailed scientific models of molecular manufacturing. His works transformed nanotechnology from theory into a tangible, multidisciplinary science that today includes chemistry, physics, and biology. Nanotechnology extends across many fields. It extends into nanofabrics, bioengineering, defense and security, nanobiotechnology, optical engineering, energy, cosmetics, so on. So, in energy, nanomaterials enhance battery efficiency and solar cell performance, while in defense, nanocoatings improve strength and protection of the equipment. In cosmetics, nanoparticles allow better absorption of active ingredients. So each field leverages precision, strength, and efficiency at the nanoscale. So, what's the difference between nanotechnology and nanobiotechnology? Nanotechnology builds the tools, while nanobiotechnology uses those tools to enhance life and health. If anything at the nanoscale, any device used at the nanoscale, when it is used to enhance life and health, it can be considered as a nanobiotechnology. So, what is nanobiotechnology? It integrates biological molecules with nanoelectronics and materials, combining the specific binding and recognition capabilities of biological systems with the sensitivity and miniaturization of nanotechnology. This integration enables the creation of biosensors, nanodevices, and molecular diagnostics. Some applications of nanobiotechnology include medicine and drug delivery, like the liposomal and polymer based nanoparticles that transport drugs directly to diseased tissues like tumors, for example, Doxil. And it's also used for diagnostics and biosensors, which made detection faster and more accurate. common example is the COVID-19 antigen test, which uses gold nanoparticles to detect viral proteins within minutes. Another is through vaccines like the Pfizer, BioNTech, and Moderna COVID-19 vaccines, which uses lipid nanoparticles to safely deliver mRNA into human cells, prompting immune protection. This innovation demonstrates how nanotechnology can support biological defense at a molecular level, revolutionizing preventive medicine. Last but not the least, nanobiotechnology can be applied in agriculture and food industry. For nanosensors detect soil nutrients and pathogens, while nanoencapsulation enhances nutrient delivery and prolongs food shelf life. These advances ensure better crop yields and safer food production, proving that nanobiotechnology extends beyond medicine to address global needs. That's all, and here that's all for this presentation. And here are the references for further reading.